let's talk about overhead versus RAID. So you have replication, you have erasure coding. In traditional NAS, you can create copies, right? In traditional NAS, you can also use RAID, and RAID is very similar to erasure coding. Erasure coding is just more of a file-based or object-based kind of RAID, or using parity segments. But why don't you walk everyone through the overhead, what that actually means when you apply it to your volumes?
Sure. I mean, what we have here is what amounts to a reasonably simplified representation of the differences between the various approaches. In the file system side of the world with traditional RAID, such as RAID 5, you have your overhead for the file system itself, the RAID overhead and whatnot. And after the file system has been formatted, of course, you have things like 10% min-free and so on that are associated with that. And ultimately, you have a pool of usable storage that's at a given amount. Moving to the right, we have the replication approach using 2 replicas on JBOD. There's no RAID overhead involved at all. And in fact, in our solution, there's no file system overhead involved at all either. It's the volumes that are used purely for storing the data. There's a little bit of overhead for some journaling that needs to take place, but otherwise, what you see is what you get with replication. You're going to have, with 2 replicas, you're going to have 50% overhead is what it amounts to, or I'm sorry, 100% overhead. But in the case of erasure coding, you can start tuning down that overhead dramatically. So what you have here on the far right is you have a 10-2 erasure coding scheme where you have 10 data segments and 2 parity segments laid out on just a bunch of disks. And as you can see there, the overhead for that is much lower. And the overhead constitutes basically the parity, and then of course the perhaps a very small portion of journaling that takes place for the volume. And as a result, your usable storage for laying out data in that fashion within the object store becomes much larger, and you have much better efficiency to work with there as a result. What we're assuming here, of course, is that we're working with the exact same pool of hardware, and we're just adjusting the efficiencies based on the various approaches that could be used with that hardware.